Hi guys, so today we're going to look at some extra features of rational graphs, but the process we're still going to use all the same pieces that we did last class. We just have about two new things that we also need to look for whenever we're graphing. So the first of those things is a slant asymptote. So one of the things we talked about was when the degree on the top was higher, there was no horizontal asymptote. But if it's actually 1 degree more, there's going to be a slant, or sometimes called oblique asymptote. So the way we find a slant asymptote, it's really easy. We divide. Either synthetic division or long division, depending on the problem. But what's nice is that we can ignore the remainder. Because if you remember, the way we wrote the remainder was something like 3 over x minus 7. And we can't really graph that as part, well, we can't do 2x plus 1 plus that little fraction. We can't really graph that. So we're just going to use just the actual quotient. All right, so let's look at this first example. Now again, whenever it comes to graphing rationals, our first step is always to factor. So I'm going to start by factoring the top. The reason I do that is because I need to make sure there aren't any factors that cancel out. So in this case, nothing cancels out, we're fine. So now let's go through the same process. So vertical asymptote, set the bottom equal to 0. So there's one vertical asymptote. Okay, then we'll do horizontal asymptote. Well, top heavy, there's none. But it's 1 degree more, so there is a slant asymptote. So what we're going to do is we're going to take x squared minus x minus 6 and divide it by x minus 2. Well, this is a case where we can use synthetic division. So remember, if we're dividing by x minus 2, 2 goes in the box. I write my coefficients, bring down the first number, multiply, add down the column. And again, we can ignore the remainder because it's not going to affect our line that we're writing. So remember, our answer is 1 degree less than the original. So this line is y equals x plus 1. So what I'm going to do is I'm just going to graph the line y equals x plus 1 as a dotted line. That's a y-intercept of 1 with a slope of 1. And that is my asymptote. So it functions just like a horizontal asymptote. You can cross it, but the ends will always go towards it. It still shows us our end behavior. All right, now let's find the other features here, just like we did last class. X-intercept, set the top equal to 0, so there's 2 of them. So 3, 0, and negative 2, 0. Y-intercept, plug in 0 for all those x's, and I get 0, positive 3. So now I'm going to sketch my graph. Well, again, just like we did with horizontal, we got to figure out kind of which box we're going to draw this in. So to the left of this asymptote, I've got either here or here. So it's still a little box even though it's slanted. Well, I already have 2 points in this top left box. So one of those curves is going to go up there. Now I've got the option of this box or this box. Well, again, I've already got a point here. That also follows my asymptote rules. At the vertical asymptote, the factor wasn't squared, so my graph is going in opposite directions. All right, domain, range, and end behavior. So the domain of this graph, negative infinity until 2, parenthesis, picks back up at 2, keeps going to infinity. Range, though, is a little bit different than what we've seen in most of these graphs. This range is actually negative infinity to infinity. There's nothing that stops it. End behavior is also different because our end behavior is no longer going towards the horizontal asymptote. Our end behavior is going, as x approaches negative infinity, that arrow continues to go down. So y approaches negative infinity. As x approaches positive infinity, that arrow keeps going up. So y approaches positive infinity. All right, so let's go ahead and do one more. Again, factor first, make sure nothing cancels. Difference of cubes. So first one is cube roots, then we square the first, change the sign, multiply, square the last. Then on the bottom, we look and see what multiplies to negative 3 and adds to negative 2. Nothing cancels, so let's go through our steps and find all of our features. Vertical asymptote, bottom equal to 0. So I got x equals negative 1 and x equals 3. Horizontal asymptote. This one's top heavy, so there's no horizontal, but there is a slant. This time, though, for the slant asymptote, we can't use synthetic. We need to use long division. So remember, when we do long division, we look at just those first terms. So x squared times x is x cubed. Then I multiply x by everything. Then I subtract. So I'm going to change my sign from minus to plus, change all the other signs. So then I have 2x squared plus 3x minus 8. And then I look at the first terms. X squared and 2x squared. Well, that's going to be 2. And the nice thing here, we can stop because the remainder is not going to matter. At this point, I can see what my slant asymptote is. It's y equals x plus 2. So we're going to go ahead and graph the line y equals x plus 2. So y-intercept of 2, slope of 1. Okay, now let's find our x-intercept and y-intercept. X-intercept, there's only one, because remember, this is going to give us only imaginary numbers. So my only x-intercept is 2, 0. Y-intercept, plug in 0 for all those x's, I get 8/3. So about 2 2/3. So a little bit above 2. Well, that shows us I'm going to have to cross that slant asymptote. Okay? So from that y-intercept, I can either go down or I can go up. I can't cross the vertical asymptote. Well, I can't go down because then I'm going to create a new x-intercept. So I got to go up. This x-intercept wasn't squared, so I got to cross through it. All right, then, again, I've got two different ways to find the next part. Well, first of all, let's look at the right side. This asymptote was not a squared factor, so I'm going to go in opposite directions. Well, if I'm going down on the left, I need to go up on the right. But another way I know that it's going to be up here in this box, if I tried to use this box, I'd have to cross the x-intercept, x-axis again, and I don't have any more x-intercepts. Same thing over here on the left. If I try and make a curve over here, I'm going to create a new x-intercept, which I don't have. So I'm going to have to go in this box. It also follows the rules for my asymptotes where I'm opposite because the factor wasn't squared. All right, so the last new feature is something called a removable discontinuity. So what a removable discontinuity is basically a hole in your graph. So what it'll look like is it's a vertical asymptote is also a form of discontinuity, but a hole is a little bit different because instead of your graph going towards positive or negative infinity at that point, your graph is actually still going towards that point. And it just leaves a little open circle in your graph. So that's what a hole is. Now, the reason we get holes is because sometimes you have factors that cancel out. So if a factor cancels out, that's what we're going to get. That's when we're going to have a hole in our graph. And what we'll do is we'll just plot an open circle where that hole is. So we'll start by factoring. So x squared minus 9 factors into x plus 3, x minus 3. And the bottom is x minus 3. Well, we can see x minus 3 cancels out. That means there's going to be a hole in my graph. The x-coordinate of the hole is the 0 of the factor I canceled out. So since I canceled out x minus 3, positive 3 is the x-coordinate. If I canceled out x plus 10, negative 10 would be the x-coordinate. All right, so 3 is the x-coordinate. Once it's canceled out, I'm going to rewrite whatever function's left over. In this case, all that's left is x plus 3. To get the y-coordinate, I take 3 and I plug it into x in that remaining function. So 3 plus 3 is 6. So this graph is going to have a hole at 3, 6. So all I do is I go to 3, 6, and I'm going to draw an open circle. Well, now the rest of my problem, I'm just going to graph the remaining function. This one's a little bit special because my remaining function is y equals x plus 3. That's not a rational function. It's a line. And lines don't have vertical asymptotes. Lines don't have horizontal or slant asymptotes. They do have x and y intercepts, but they don't have horizontal or vertical asymptotes. So I'm just going to graph the line y equals x plus 3. So y-intercept is 3. Slope is 1. And if I continue that slope, I would have an x-intercept of -3. Domain. So domain, we always exclude vertical asymptotes. We also exclude holes. So the domain here would be -infinity to 3 union 3 to infinity. All right, so let's go ahead and try another one. Again, you always have to factor first because you never know if you're going to have a hole in your graph. Even if you only want to find the vertical asymptotes, you still need a factor first because you don't know if there's going to be a hole there instead of a vertical asymptote. So the way we're going to factor this on the top is we're going to start by taking out our GCF, okay? That is an important step for factoring because otherwise you may miss that there is a hole there. So 2 comes out, I'm left with x minus 5. Then on the bottom, this is going to be x minus 5 and x plus 2. So we do get a factor that cancels. X minus 5 cancels out. Since x minus 5 canceled, the x-coordinate of the hole is 5. To find the y-coordinate of the hole, let's look at the function that's left over. So take 5, plug it in to the remaining function. So I get 2 over 7. So I'm going to go to 5 2/7 and make an open circle. Then I'm going to finish this graph for the remaining function the exact same way we did all last class. Vertical asymptote, set the bottom equal to 0. Horizontal asymptote, okay, this one is bottom heavy, so there is a horizontal, it's y equals 0. X-intercept, set the top equal to 0. Well, it's just 2, so that's not going to happen. Y-intercept, plug in 0 for your x's, and I get 0, 1. So now, sketch our graph. Well, on the right side here, I know I'm going to be in the top right box because I've got the point, and I have to go near that hole. Factors weren't squared, so I'm going to go in opposite directions at my vertical asymptote. Again, if you're not sure, you can pick a test point, plug that in. That would give me 2 divided by a negative, which is a negative value. All right, domain. Remember, we exclude both vertical asymptotes and holes. So this would be from -infinity until the vertical asymptote. Then it picks back up until the hole, and then it keeps going to infinity. All right, let's just do a couple more. This one's kind of a special case, a little bit different, but again, start it the same way. Let's factor. Okay, x minus 5 cancels out. So we think that we're going to have a hole at 5 comma something. Well, let's plug in 5 to the remaining function. Well, that gives me 6 divided by 0. 6 divided by 0 is undefined. So there actually isn't a hole. The reason is because since that factor is still there, there's actually just a vertical asymptote there. So that vertical asymptote is really going to be, since that vertical asymptote is still there, we're not going to have a hole there because you can't have any points on that vertical asymptote. So this is kind of a special case. All right, now let's go ahead and finish this for all the same parts. Horizontal asymptote, same degree, divide the leading coefficients. X-intercept, set the top equal to 0. Y-intercept, plug in 0 for your x's. So I've got 0, -1/5, and -1, 0. Well, that hopefully makes it clear that I'm going to be in the bottom left quadrant. And because that factor wasn't squared, I'm going to be in the top right. I also know I'm in the top right because I can't create any new x-intercepts. Domain, -infinity until 5, keeps going from 5 to infinity. All right, so same thing here. We're going to go ahead and factor. Well, this time a is greater than 1, so I got to go through that longer process. What multiplies to +4 and adds to +1? Well, that's going to be a -2 and a -2. So 2x comes out. So I get 2x minus 1 times 2x minus 1. So I can write that as 2x minus 1 squared. Some of you may have noticed from the beginning that that was a perfect square. And if you did, great. It's going to save you a lot of time. If you still have to go through that process, there's nothing wrong with that. All right, so this time, there's no hole. No factors canceled out. Vertical asymptote, we set the bottom equal to 0. And that factor was squared. That means at that asymptote, my graph is going to go in the same direction on both sides. All right, this one is going to have a horizontal asymptote because it's bottom heavy. So it's y equals 0 for that horizontal. X-intercept, set the top equal to 0. So let me go ahead and plot that point. It's on the axis. Y-intercept, let's plug in 0. Oh, let's plug in 0 to the original, makes it a little easier. So I get 0, negative 2. All right, so what this tells me, again, if you're not sure, pick a test point, plug it in, okay? Plug in negative 4 and see, do I get positive or negative numbers? I'm going to end up with a negative in that point. But I also know I'm going through 0, negative 2, so I have to be in that bottom left box. Now this factor, like we said, this asymptote this time was squared. Since that factor was squared, on the opposite side, I'm going to go in the same direction. Now this one's a little bit weird because, again, the x-intercept is on the asymptote. It wasn't squared, so I have to cross it, but I'm not just going to cross it for forever. I'm going to cross it and go towards my horizontal asymptote. So this function's domain, we just exclude that vertical asymptote. All right, let's try the last one. So this one's going to kind of have a little bit of everything. So the first thing we're going to do, factor. Take out our GCF from the top. Take out our GCF from the bottom. Let's continue factoring the top. And now we're factored. So first thing we look for, do any factors cancel out? And we do have a factor that cancels out. It's x. That means there is a hole. It has an x-coordinate of 0. Well, now we look at our remaining function. I plug in 0. Everywhere there's an x. And actually, to make this a little bit easier, I'm going to go ahead and also FOIL this out so you can see the remaining function in standard form, because we'll need that for division anyway. So x squared minus 3x plus x is minus 2x. So that's the standard form version of this function now. So let's go ahead and plug in 0. That gives me negative 3 over 2. And that's my hole. All right, vertical asymptote, set the bottom equal to 0. X equals negative 2. All right, then from this point, this is top-heavy. The remaining function is top-heavy. So what we're going to do is find the slant asymptote. So in this case, we're going to use division, and we can actually use synthetic division. Now the thing, though, again, if you didn't FOIL this out, you're going to want to in order to do this division, because you can't really divide negative 2 into x minus 3x plus 1 without FOILing it out. So to do synthetic division, we need to have those coefficients. So those coefficients are 1, negative 2, and negative 3. Bring down the 1, multiply, add, remainder doesn't matter. So our slant asymptote is y equals x minus 4. All right, let's do our x-intercepts. Set the top equal to, well, let me go ahead and graph that first. So x minus 4, y-intercepted negative 4. And there's my slant asymptote. All right, x-intercept, set the top equal to 0. There are two x-intercepts, 3, 0, and negative 1, 0. So I'm going to go ahead and plot both of those. And hopefully you're starting to see this gives you a pretty good picture of what your graph is going to look like. Y-intercept, a little bit different here. We got to be careful. Okay, if I try and plug in 0 to this remaining function, I'm going to get 0, negative 3 over 2. But if you notice, we already have something at 0, negative 3 over 2. It's a hole. So this graph does not have a y-intercept because there's a hole there. So now let's go ahead and sketch our graph. Well, I can hopefully see I need to go towards that vertical asymptote and through these points and cross through those points and then go towards the asymptote. So one of those curves is hopefully pretty clear. To get the second one, I'm not going to go in the same direction because the factor is not squared. I also can't create a new x-intercept. So I have to be in that bottom left box. Once our graph is drawn, we'll find domain. So negative infinity to negative 2. Picks back up at negative 2. We also have to exclude the hole. And that is my domain. All right, so if you guys can graph this one, you guys can do basically everything for a rational function. Again, if you're just struggling with the drawing of the graph, that's okay, but we got to be able to find really all of these features here, and that's really the most important part. But again, we're going to do a lot more practice on this in class before we got to take our quiz.